I welcome you all in this presentation related with the subject materials processing fundamentals and practical. And we are talking about the metal casting. So, in the previous presentation I talked about the overview of the metal casting process as a whole. In this particular presentation I will be talking about the patterns, pattern material, pattern allowances, and what is the role of these in developing the sound castings. And also we will be talking about the molds as a part of the gating system and how it contributes in development of the sound casting. So, as far as the content is concerned, we will be talking about the pattern and the design aspect, especially the allowances and the material, how these play a role in shaping and sizing of the material. Apart from the sizing of the pattern, apart from that we will also be talking about the characteristics which are important for making a pattern. Okay, characteristics of material, okay, for making the pattern. So, about this also we will be talking. Then in the mold, mold is one part of the gating system. It is a cavity where molten metal is filled. For molten metal is filled for developing the casting. So, but it is a part of the gating system. Okay. So, there are a number of components like pouring basin, then sprue base, runner, and then in gate and a riser. So, the mold is one component in this. So, the mold can be made of the variety of the materials. So, mold material most commonly for low volume, high variety production of castings, we basically use the sand mold, okay, and but metallic molds which are called die are used when the variety of the designs are very limited and the volume of the components to be produced or the number of units to be produced is high. Additionally, the quality requirements are also high in terms of the dimensional control and the surface finish. Then we go for the metallic mold. Additionally, we can use the plastics and then we can use so these two are the most commonly used one. And then for realizing the desired sound casting through the directional solidification, which helps in developing the sound casting, what we do, we try to control the temperature gradient within the molten metal. Okay. So, this a favorable temperature gradient in the molten metal helps in realizing the directional solidification, and once this is realized, then the chances of realizing the sound casting, those are increased. So, this suitable temperature gradient is realized with the help of chaplets and chills. Okay. So, this is about the various aspects about which we will be talking. Okay, so we know that for making product, say there is a product which is to be made by casting process. Okay, so first we have to make the model or replica of the product to be made. Okay, this replica will be used for making the mold. Okay, once the mold is made with other components of the gating system, we will be filling in the molten metal in the mold cavity, molten metal in the mold cavity, followed by solidification of the molten metal. We will be getting the metal casting of the desired, of the size close to the desired one. Okay. So, in this sequence, if we see, for making a product by casting, first of all this the model or replica is to be made. Okay. Then so, and thereafter the mold thing will come. So, as far as the pattern or the replica or the model of the product, this is known as the pattern. Okay. So, the design of the pattern, like especially the size and the shape, this depends on the multiple factors like the metal, especially the thermal expansion coefficient related with the metal and the complexity of the design, complexity of shape of the product. Okay, this is another. So, and the various allowances which are to be given to the pattern. So, they will be affecting not just the size, but also the shape. Shape is affected primarily considering the distortion possibility. Okay. So, considering the distortion possibility, sometimes the more pattern is given the shape different from what is the desired in a final product. So, that is why what we say pattern is made of the size and shape similar to the product, not exactly of the size and shape of the product desired, but it is close to the one which is desired in terms of the size and shape. Okay. It is similar or nearby, not exact dimensions. Okay. Why? Because we need to provide many allowances for taking care of the multiple aspects like the shrinkage, okay, like the machining allowance, like the distortion allowance, and then there is in case of the sand mold casting there is a draft allowance, okay, and the wrapping allowance. So, all these allowances force us to use the pattern of the size which is not exactly same as that of the product, but it is different. Okay. Now, the pattern material, there can be multiple types of the pattern materials. The most common one is wood, okay, and then the metal, then there is a possibility of using the plastics and then wax. So, depending upon the volume of the castings, number of units to be produced, okay, the quality requirements in terms of the like the complexity of the shape and the surface finish, the dimensional control which is desired, and the fineness of the various features in the casting. So, that will be determining significantly the kind of pattern material to be used. Oh, and above over and above these points, there is also possibility that we should see like how frequently the design can change, frequency of the design change. You see, so if the design can change very frequently of the product, then we will prefer to go for the wood as a pattern material rather than the metallic patterns. Okay. So, here if we try to see, so the other aspects like the selection of the pattern material is based on the volume, that is the number of units to be produced, how frequently the design change is possible. If the design change is not possible or design change is not needed in the short term, then we can go for the metallic patterns, and then quality requirement in terms of the surface finish, tolerance and shape complexity. All these factors affect the kind of pattern material to be used. So, the most common pattern materials are like wood. So, the wood, the good part with the wood is that it is cheapest, okay, and easy to process, means you can easily give the desired shape and the size. Desired shape and size can easily be given. So, it does not offer any issue with regard to the manufacturability of the pattern, it is low cost. Okay. But there are many issues with the wood also, that because of the continuous rubbing there is a possibility of the abrasion. Okay. And if the moisture is absorbed, then so the moisture is the another factor. If the moisture is absorbed, so abrasion coupled with the moisture absorption possibility, both these tend to change the tendency of changing the shape, okay, changing the shape of the pattern and even size of the pattern. So, if the size and shape of the pattern is modified, then accordingly our the mold shape will be modified and we will be getting the product of the size and shape which is not desired. Okay. So, purpose of making the product by casting route will be modified. So, we need to be very careful regarding this aspect of wood, although it is cheapest, but it suffers with the change of shape and size due to the abrasion particularly and the moisture absorption. Okay. So, which can lead to the distortion. The metallic mold. Metallic molds are particularly preferred for the high volume production. Okay. So, high volume production, so these are justified, so and these are costly also. Okay. So, because of the high coupled, the metallic patterns are costly to make. So, these are justified only when the number of units to be produced are very high and there is no frequent change in design. So, if that is the case, then the metallic molds are preferred. But you see, since the metals offer the higher density as compared to the wood. Okay. So, the patterns are heavier, metallic patterns are heavier, and when the pattern is heavier, then these cannot be used for making very large size patterns, not for very large size patterns. This is one, and these cause lot of fatigue to the workers because of the heavy weight of the pattern to be used for preparing the mold. Okay. So, the good part is that with the metals they offer very good surface finish. Okay. This is one, very close tolerance is maintained, and the dimensional stability is also good. Why? Because it's not very sensitive to the moisture absorption or the abrasion kind of thing. Okay. So, surface finish, dimension tolerance and the dimensional stability is good. On the bad part is, you see, these are justified only for the high volume production. Okay. No frequent change is allowed, no frequent change in design. Okay. And third, these are heavy. So, because of the heaviness, these cause fatigue to the operator. Okay. And as far as the plastics are concerned, certainly these are very light in weight. Okay. And easy to process to get the desired size and shape. But the issue is the abrasion. You see, abrasion means when sand is continuously rubbing the plastics, so abrasion will be changing the size and shape. So, the life will be limited. So, the life is limited means, so we need to go for the frequent replacement of the plastic patterns, although these are not sensitive for moisture absorption related issues. Okay. So, these are light in weight, easy to process in to get the desired size and shape because of the low melting temperature. But when these are used continuously, they suffer with the abrasion due to the continuous rubbing with the sand, and that in turn changes the size and shape. Therefore, the life is limited and these are not sensitive. The good part is these are not sensitive to the moisture absorption. Okay. For wax patterns are particularly used in case of the investment casting. Okay. So, about this we will be talking a little later, because the first we make the wax pattern, then this is used for making the mold. Okay. Then that mold is used for making the castings later. Okay. Now, going ahead with the important characteristics that a material should have, as we have talked about, like when we are dealing with the multiple options for selecting a suitable pattern material, like the wood or the metal or the plastics or the wax, then what we need to see is the ease of manufacturing, like how easily the desired size and shape can be obtained to make the pattern. The light weighting will allow the easy working without causing much fatigue to the operator for making the mold. Okay. Resistance to the wear, because the pattern will continuously be rubbing the surfaces of the pattern. So it is important that there is no loss of dimension of the pattern due to the wear. So, whether it is abrasion, corrosion or any other kind of the chemical attack which is happening on the pattern surfaces during the molding process. Okay. And then dimensional stability against the variation in temperature and the moisture. Okay. So, the dimensions should not change, because if the dimensions change, then the mold size and shape will change, and that in turn will result in the casting of the size and shape that is not desired. Okay. So, as I have said, the design, like size of the pattern significantly governed by the various allowances to be given. Say for example, say if there is a product of say 100 by 100 square section, okay, which is to be made, then pattern need to be made, say in this case solid case, the pattern need to be made a little bigger, because it can be made little bigger, so that when it solidifies, after solidification, when it shrinks from the solidus temperature to the room temperature, whatever shrinkage is taking place, that is compensated. So, like say if we give the allowance of 5% to particular dimension, then the dimension of a product which is desired is 100, then the additional material, that will be additional dimension, additional material will be given in form of additional allowances in form of like say 105 to all the sites. Okay. So this is how we provide so in this case our pattern will be little larger than the size of the product to be made, because this 5% additional allowance is being given to take care of the shrinkage of the metal that will be taking place after the solidification during the process of cooling down to the room temperature. Okay, so here if we see which aspect is taken care of, say we know that this is the temperature in y axis and in axis there is a time. So if we try to draw the see the cooling curve, it comes in like this. So this is the liquid state, this is the undercooling zone, this is where solidification starts. Okay, solidification starts, this is the undercooling zone, and then here solidification completes SC. Okay, and here once the solidification completes, then we will be having the cooling down to the room temperature. So whatever shrinkage is taking place in this zone, like in the solid state, whatever the shrinkage is happening, that is taken care of by the shrinkage allowance. So shrinkage allowance provides the additional material to take care of the solid state shrinkage. Okay, if we see the shrinkage which is happening like this during the liquid state, like on this is the like the liquid state, this is the undercooling zone, and this is the zone where the solidification will be taking place over a range of temperatures. So whatever is the shrinkage which is taking place in the molten metal during the solidification, whatever is the shrinkage taking place during the solidification, that is taken care of by the riser. Okay, by feeding the extra amount of the molten metal to the mold. So these are the two different things. Okay, one is the liquid state shrinkage, okay, shrinkage which is taken care of by the riser. Okay, and the solid state shrinkage is taken care of by the shrinkage allowance given to the pattern. Okay, shrinkage allowance to the pattern. Okay, so that primarily depends on the two aspects. One is the thermal expansion coefficient, thermal expansion oblique contraction coefficient. Okay, alpha, this is one. Higher the value, greater the shrinkage allowance need to be given. Okay, and the second is the dimension. Okay, so since it is given as a percentage of the particular side where it is to be given, so the dimension is the another thing that affects the the final size of the pattern. And the third is the location of surface, whether it is external or internal. Okay. So this is how we try to these are the various factors that will be affecting the shrinkage allowance. Okay, the machining allowance, if we see, because after the casting we get the products which are usually of the size and shape is such that this is not directly ready for use, Okay, these are not readily suitable for use directly, because their dimensions and the surface finish, these two aspects may not be as good as that is desired for a particular application. Okay, so it is required that the desired dimensional control and surface finish is realized by machining. Okay, to machine out the material and realize the desired dimensional control and surface finish, it is important that material is provided. So, what we do, we provide the extra material to the pattern. Okay, like say this is the final size and shape, this is the product of the desired surface finish and the dimensions, but this can be realized only after the machining. So if the we have to make the casting of little larger size, so that extra material can be provided for the machining, we need to provide the machining allowance. Okay. So, machining allowance is provided by providing the some allowance to the pattern, so that the pattern is a little larger, so that we can, when the product is made, casting is also larger, okay, using that particular mold. So, we will be making the first pattern of the larger size, then accordingly we will be getting the larger size mold, then larger size casting. Then once the casting of the large size is obtained, which is really not really of the desired size and shape and the dimensions, then we need to realize that by machining. So, with this extra material which has been provided by providing the machining allowance need to be removed by machining. Okay. When machining is done, it will help in realizing the desired the dimensions. Okay. So, now depending upon the kind of the surface finish desired, the location where the component surface finish and dimensional control which is desired, and the location of surface, the machining allowance and the type of metal also affects the kind of machining allowance to be given. The draft allowance is particularly is important for the pattern and being used for making the sand mold. Okay. So, here in this case what we do, like say if the product is made like this, product is like this, and around that we have packed the sand very tightly during the molding process. Okay, like this, and this is the flask. Okay, and now after packing this is a pattern. After packing the sand, the pattern need to be taken out, so that the mold cavity can be realized of the desired shape and size. Okay. So, this pattern is taken out. When the pattern is taken out, the vertical surfaces tend to damage the wall, mold wall, okay, which will be realized later. So, while taking out there is a high tendency of damaging the vertical surfaces of the mold by the pattern itself, and that it can lead to the damage to the mold wall like this. So, to avoid this kind of damage, what we do, instead of making the pattern with the vertical surfaces, what we do, some kind of the taper is given to the vertical surfaces, which can be like 3 to 5 degree. The taper is given, and then around that we will be packing the molding sand, okay, like this. Molding sand is packed. So, when this kind of the pattern with the taperness it is taken out, the tendency to damage these surfaces, that will be these vertical surfaces, these will be minimized. Okay. So, the main purpose of giving some kind of the taperness to the vertical surfaces of the pattern is to reduce the damage to the vertical surfaces of the mold wall. Okay. And this is provided by giving an angle of 3 to 5 degree to the vertical surfaces. So, there are two aspects. If we are talking about the external surfaces, then we need the less draft allowance, that is like being given 3 to 5 degree. And if it is about the internal surfaces, then the more draft allowance is given. Draft allowance is greater, maybe 5 or 6 degree for the internal surfaces, in order to reduce the damage. Okay. So, the draft allowance is given in degrees to the vertical surfaces of the patterns, so that the damage to the mold surfaces can be minimized. Okay. Now, sometimes the distortion allowance is given, like say if you want to make a T shaped product, and then if we find that there is a tendency of the distortion to one side, and it is getting distorted in one side like this, then what we do, we try to give the shape such that the pattern is distorted in opposite way. Okay. So, the pattern that is made to incline in other direction, so that after shrinkage and after the contraction it becomes vertical. So, if it is getting, we want this kind of product, this is what is desired A, but instead of getting A we get B because of this distortion tendency. So, to neutralize this distortion tendency and obtain the product like A which is desired, so the B is not desired. So, what we do, pattern is modified to the shape which is not desired. So, what we do, pattern is made to made in such a way that the shape is oriented in direction opposite to that of the direction in which distortion was taking place. So, that when it shrinks and the distortion takes place, we get the normal, the desired product or the component. So, we want A, but we are not able to get A, but we get B due to the distortion tendency. So, we make the pattern using the distortion tendency, where pattern is made to orient in the direction opposite to that of the direction in which the distortion was taking place. So, that after solidification, after cooling down to the room temperature, we get the product like A. Okay. So, distortion allowance is just like making the product of the shape which is not desired, but it considers the distortion tendency to get the desired product. Then the wrapping allowance, sometimes what happens, like say this is the pattern, okay, and the molding sand is all around this and it has been rammed. Okay. So, now once it is rammed, then the molding sand will be attached and maybe adhered to the pattern surface very firmly. So, to taking out the pattern out of the mold without damage will be difficult. So, what we do, we try to do the little hammering lightly, so that the pattern in the pattern is loosened basically. For the loosening the pattern in the with the molding sand, this tapping is done using the wooden hammer. Okay. And then once it is loosened, then it is taken out. So, what happens in this case, because of this loosening, the size of the mold is enlarged little bit, size of the mold is enlarged. Okay. So, we need to so this is the allowance which is the negative one, other allowances are the positive one. So, you see, draft allowance is for vertical surfaces, distortion allowance for considering the distortion, machining allowance, and these two are the positive allowance where the larger dimensions are realized in the pattern. The wrapping allowance is one where which is the negative allowance, and we want to make the pattern of the smaller size, considering the tendency of increasing size due to the tapping of the pattern while taking out the pattern from the mold. So, these are the 5 types of the allowances which are considered, and these allowances result in the pattern, okay, of the size and shape which is really different from the product desired. Okay. So, that is why we say that the pattern is not exactly of the size and shape which is desired, but it is the close to one which is desired. So, here I will summarize this presentation. In this presentation, basically I have talked about the pattern and the various allowances to be considered, pattern material and the various characteristics desired for making the pattern. Thank you for your attention.